looking at this question, it says the national freshman to sophomore retention rate has held steady at 74%. A certain college has 504 of 609 freshmen return as sophomores. Does this college have the right to brag that it has an unusually high retention rate? Okay, now this is applying the sampling distribution model for a proportion. What we're going to say is if the true value of the retention rate is what the national average of 74% or 0.74, how unusual is it for a college to have 504 out of 609 freshmen return as sophomores? Well, you know, to figure out how unusual something is, you want to compare it to the mean, which here is the 74%, and then, but we need it in terms of a standard deviation. So if we think of a z-score, if we calculate the z-score for this 504 out of 609, it's going to tell us how, in terms of standard deviations, how unusual that number is. So if we're applying the sampling distribution model for proportions, we have to look at the assumptions. The independence, you know, the fact that one freshman returns probably doesn't affect another. Random sampling, we're not really told. We're hoping this college is a representative sample. That's a little bit dangerous there, because if it's a private college, a lot of private colleges have much higher retention rate than some of the public universities, so it depends, or a highly selective college. We expect at least 10 successes and 10 failures. Well, we have 504 what we would consider successes because they returned, and so it would be 105 because there were 609 total, so 105 failures. So that's both greater than 10. Then the sampling distribution of a proportion is modeled by a normal model with a mean equal to the true proportion value, which is that 0.74, and a standard deviation equal to the square root of PQ divided by N. Okay, so let's figure out what the standard deviation would be here. It's going to be equal sign, and then you'll do the square root. The P, which is what is assumed to be true, the 74%, 0.74, times the Q, which is 1 minus 0.74. So what's that, 0.26? And you're going to divide by N, which in this case is the 609. All right, so this is our standard deviation in this situation. So we have a normal model with a mean of the 0.74 and a standard deviation of 0.0177. Now let's look at our data. Our data is the proportion of students that return at this one college that we picked it, which is equal sign 504 divided by 609. Let's see what that college retention rate is. Okay, their retention rate is 0.8275. So what happens here is we say to ourselves, all right, how unusual is it to get a 0.82 data value if the mean is 0.74 and the standard deviation is 0.017? And there's lots of ways to do this. You could actually use the normal model and get a probability of that occurring, or you could just get a z-score. And the reason we're going to get a z-score is because these multiple choice answers are talking about, it's really talking about a z-score, because remember, the z-score is the number of standard deviations you are away from the mean. So let's just recall the z-score is equal to the data value minus the mean divided by the standard deviation. Just type that to remind you. So in this case, we'll do equal sign and then parenthesis. The data value, which is this in 0.827, I'm going to grab that, that's in C26, minus the mean, which is the true value. And then we're going to close that parenthesis and divide by the standard deviation. So in this case, look at that, 4.927. A z-score of 4.927 is very far to the right. So this college does have a right to brag. It does have an unusually high retention rate. And so that would be yes, because the retention rate is over 4 standard deviations above the expected rate of 74%. Okay.